Alright, I made two videos where I went through this entire star test from May for the algebra EoC, and in case you don't want to watch the whole thing, I thought I'd make a summary like a TLDR version. So there's 6 main skills that I found to be helpful in working through the star test, and I want to go through a brief example of each. And then here I've made notes of all the problem numbers in which these methods or tricks are helpful. So you'll see some of them are helpful on a lot of numbers and some of them on not as many, but I think all of these are really good things to be aware of and to know about the capabilities of Desmos. So I'd recommend watching this video, and then if there's one you want to know more about, go to the long video and you can skip to these certain question numbers that are the ones that you want more practice with. So starting out, some basic stuff with Desmos is knowing what it can do. So one thing that you may not know it can do is that you can substitute values for letters. So I can do something like A equals 2, B equals 3, C equals 5. And anytime you need to substitute values into an equation, so this could be, or an expression, so something like working with simplifying radicals or laws of exponents, this is a really helpful trick to substitute values. And the thing you need to know is that you can only use non-reserved letters. So you can't use X, Y, E, R, and a bunch of other things. So my recommendation is whatever letters are in there, just change them to A, B, C, D, and then assign them unique prime values like 2, 3, 5, 7. So however many letters you need, just give them each a value, and then you can type in their thing. So let's go look at one example of that. So number 16 is a good example. So there were C and D were the two values. I don't need any others. And since C and D are in my list, I'm just going to use C and D. But if you look at like number 23, it had R, T, and W. So for that one, I had to use different letters. So for 16, I would just type exactly what's shown here and then exactly the answer that I got, and they'll give me the same kind of nonsense number. So C to the 8, and then parentheses, D to the 6th, parentheses, and then raised to the 3rd, and then on bottom C squared. So it looks exactly like on the paper. I get this nonsense number, and then when I type in my correct answer, which would be 8 minus 2 is 6, that's 18, so that would be J. I type C6, J8, or D18, making sure everything's in the right spots, and those match, so I know that that is the correct answer. So substituting values is a really helpful thing to be able to do. There's only a couple examples on here that I saw where it would be useful, but it's useful on several different topics within Algebra 1. Next thing I wanted to look at is just graphing in general. There are so many problems on a star test where graphing is absolutely trivializes the difficulty of the problem. So I'll show a couple of those, but there's lots here. So if you want more examples, you can go to those in the longer video. So here's a system on number 3. It says which one is represented by the graph. I literally can just graph what I see in these answers. Y equals 2 over 5x minus 8, and y equals negative 3 over 5x minus 3. That one doesn't match the picture, so I move on and graph the other ones by changing these numbers around. So the key things to keep in mind with graphing are you generally want to graph with y and x as the variables. So if they give you different letters, then use those letters instead. And there's, like I said, there's lots of examples of graphing and how it can be helpful. It helps with tons of things. But another spot that graphing can help is, I'm going to skip down to graphing systems. So if I have a system of equations, the thing to keep in mind with graphing, whether it's just basic graphs or graphing systems, is that they have to be in y equals format because of the star restrictions. So if I try to type 2x plus y is equal to 40, it doesn't like that. It says plotting implicit equations is disabled. So what I showed in the other video is just do your basic algebra. Like here we have 2x. I need to move that to the other side, so I'll put minus 2x to move it over. And then if there was something in front of the y, I would just divide all of this together by whatever's in front of y to get rid of it. Since there's nothing in front of y, then that's all I need to do is graph that, and I get my line. And then for systems, I'm looking for where the two lines cross. Generally, I'm looking for the x value or the ordered pair. So I need this x on the other side, so I'm going to do minus x to get rid of this. And then there's a negative 2 in front of the y, so I need to divide all of this by negative 2. And it does not matter that it's in a really ugly form. It still is going to give me my solution of 12, 16, and that's that. So systems, whether they're written out in a format for you to do substitution and elimination, or whether they're already a graph, are very easily solved by graphs. Next thing I want to look at is evaluating and transforming functions. So on number 13, we have a function transformation. So the thing you may not realize you can do here is if you put f of x equals and then type your function, you can apply transformation rules to it directly. So not relevant in this problem, but I could do a transformation notation like 2 f of x minus 3. And that will vertically stretch it by 2 and shift it to the right by 3. And it's written as the transformation rule. In this case, it's written as the transformed function, so I could put x squared, if I could type, x squared minus 1, and I can compare these two to determine what the change was here. So looking at the red and the blue, I can see that it shifted down and answer that. So I can do all kind of stuff with transformations. I can also evaluate functions. So where was one of those? Let's see. Evaluating, I think 31 is a good example. Yeah. So it says f of x is equal to 7 minus 4x. Again, that's not in a nice format, and it doesn't matter at all because it's graphed right here. So it says, what is f of negative 5? So we know that I should plug in that negative 5 here. I get a double negative, which is going to make some sign mistakes. But over here, I can literally just type in, same way I could type in transformation rules, I can evaluate f of negative 5 in parentheses, and it just tells me what f of negative 5 is. So really, really useful thing that you may not be aware of. Next thing is going to be, we'll go to linear factors of quadratics and end on what I think is the most important one of all. So let's go to 14. On 14, we have a quadratic written with d's instead of x's, so we're going to change it for graphing to x's, x squared minus x minus 6. And it says one of the factors is d plus 2, and the other is d plus k. So the thing I want to make sure you're aware of is if I knew the two factors, I could type x plus 2 and x minus 3, and I could see that the graph overlays perfectly. That's really helpful if you already know both of the factors. In this case, though, I don't. I only know the x plus 2. So I can divide this quadratic by x plus 2, and I end up with a line that is the correct solution. So it has a slope of 1 and an intercept of negative 3, meaning that it is x minus 3 is my other factor. So when you know something is a factor, remember that factor means it divides evenly into a thing. Like 3 is a factor of 6 because it divides evenly. So since x plus 2 is a factor, dividing by it gives me my other factor. It's just like if you did the division using the area model with this polynomial. You put this part in the boxes, the top part, and this part on the left, and then on top you would get x minus 3. All right, the last thing I wanted to end on is talking about regression equations. They are really, really valuable in a lot of places you may not even realize. So we can define any line in any exponential function with 2 points. If we know 2 points, that fully defines that function. A quadratic takes 3 points to fully define because it has 3 parameters, a, b, and c, or a, h, and k. So starting with number 1 here, it may not be immediately obvious how we can use this, but we're going to create a table, and we can put in these ordered pairs. So we have 5, 0, 0, 10, and 0, -2. I know this is a quadratic because it shows me it and it says quadratic function r. So it's so important that you know how to type the 3 regression equations, like the format. So to put y1 is approximately, for quadratic, ax1 squared plus bx1 plus c. And it's going to draw that parabola that's the only one that can pass through those 3 points, but it can't really because it's got this terrible r value. So there's no quadratic that fits these 3 points. Definitely doesn't look like the one in the picture. So if I change up these points and put 0 and -10 and 0 and 2 and -5 and 0, then you can see that it still isn't going through all the points. And then I could do 0, 5, which this one's kind of tricky because I need to recognize that the x-intercept is not 0, 5. And I'll show you how this one tricks you, is that these numbers actually do make the correct parabola. It goes through all 3 points, but it reversed what it's calling the x and y intercepts relative to d, which is the actual correct answer. So it can help a lot. It eliminated a and b as options, but it didn't tell us for sure what an x and a y intercept are. We have to know at least a minimal amount to know that. We'll look at a couple more of these. So number 2, this one is not a linear regression problem. It has a table though. And in a table, if we have 2 points, if it's not a regression problem, which it's not because it doesn't say which is the best fit, it just says it's a linear regression, or it says it's a linear equation, then we can do a linear regression and get the equation, and it says which one is the number of boxes per minute. So 4 is our slope, meaning 4 boxes per minute is the correct thing, or 4 items per minute is the correct thing. So you can get a slope, you can get y-intercepts from this, and normally, of course, you'd use the slope formula, but this is a fallback, something to just kind of have available if you really need it. If you totally like blank and forget everything during the STAR, regressions can save you on a ton of questions. I want to look at one more thing on regressions that we haven't seen. This one will be good for that. So this one, I have 2 points that are shown, 4, 0, and you do have to know how to read points from a graph. If not, you can't really use it for this, and 8, -7. So y1 is approximately mx1 plus b. So it says that my slope is -1.75 and my y-intercept is 7. So I know the answer is B or D. But if I don't know what -1.75 is as a fraction, you may not be aware that once m and b are defined here, then Desmos knows what those are. Like if I type in b, it tells me b is 7. And if I said like 5 times b, it knows that b represents the number 7 for the rest of like anything I type below this. So if I type m, I get -1.75. And you probably know there's a button to the left here that toggles between decimals and fractions. So I can do my regression, type in m or a or b or whichever thing I need that came out as a weird decimal, and convert it into fractions using this button. So now I know the answer is definitely the one with -7/4 and 7. One other thing with that, if you ever need to do 2 graphs on top of each other that are both done with regressions, then make sure that you give subscripts to m and b as well. So notice if I create another table and I put in 2 points like 1, 5, and -9, 12, and then I try to do a regression here and put, now you know I have to use y2 and x2 because of the headers of this table. I put y2 as approximately m x2 plus b. So my issue here is that m and b are already used. So if I go down here and type, or right here you can see where I typed m, it said you've defined m in more than one place. Try deleting some of the definitions. But if I go here and I put m1 b1 and m2 b2, then down here I can put m1 and it knows what it is. I can put m2 and it knows what it is. So using subscripts, if you're doing multiple regressions in one window, can be helpful to separate them and get those different values. And then the last thing on regressions, I forget what the last thing, let's see, let's go down the list. So 21, this wasn't regressions, but this was, I think this was the last thing. So on this one, you can type in what you see here as 8.8 times 10 to the 9 over 2.2 times 10 to the negative 3. And you get 4 times 10 to the 12. Well, I mean, that one's in the right format for that answer, but if it weren't, you could type the answers in as well to compare them, but that one just is right. Okay, I think that's all, and if you want any more examples of each of the kind of topics, this is the list of problems that I saw. One thing you'll notice is there's only a handful of problems on the entire star that one of these methods or tricks is not really able to be helped by Desmos. And those are all ones that have to do with vocabulary and concepts. So knowing words like domain, range, vertex, rate of change, slope, those kind of things are going to be important because there's no way that Desmos can tell you what those words mean. But like I said, go check the long video if you want to see any more examples, but that was just a quick overview of the things I think are most important that you know about before the EoC.